All right, for this section, we're going to be looking at trig functions of any angle, not just a regular old triangle that's acute like that. Let's look at a coordinate plane here. All right, let's suppose I have a coordinate plane, x-axis, y-axis here. And let's suppose also that I end up taking this triangle right here and translate it to this coordinate plane over here, okay? And I draw it something like, maybe pick another color here. And maybe it looks something like this now, okay? In other words, transferred it over there, kind of tilted it a little bit. So if I do that, this will be angle theta right here. I went a little overboard on the angle theta. Let's try it again. This will be angle theta right there. I'll have my right angle here. And we'll call this length right here R, this length of the hypotenuse basically, okay? And we're going to say we have a point P up here, which is given by x comma y on the coordinate plane. Now, if that's x comma y, what is this distance right here? What is this length of the triangle? Well, I go up y units, so that's going to be y as well. What about this distance right here? Or this leg? What is the length of that leg in my right triangle? It's going to be the same as that x value there. I'm going to call that x. Okay? This allows us to define the trig functions that work for acute angles, but also other type of angles as well, for any angle. For example, now I can look at something like this, an angle theta right here on the coordinate plane. All right, so let's define some stuff right here, okay? Let's say that I did do this. I put an angle theta on the coordinate plane. That angle is greater than 90 degrees. And this is a point P, which was given by the order pair x comma y again. Now, this would be R. R is that distance from the origin to that point x, y. And let's define some stuff here. Pick another color here. I'm going to say the sine, try to do that, the sine of my angle theta is going to be, well, look at this drawing right here, okay? What would we say the sine was? Sine of my angle theta is opposite, which was y, over hypotenuse, which is r. Y over r. By looking at that same triangle, the cosine of theta would be what? Adjacent side, x over r. Tangent of theta would be what? Y over x. Okay, cosecant of theta be r over y. Secant of theta would be r over x. And cotangent of theta would be x over y. Now that's assuming that like the x here, the y there, the x there is not equal to 0, okay? Now, if we define the sine to be this, sine of theta is y over r, then that works for an angle like this one right here. Because we just take our y coordinate and put it over r. Same thing with the cosine of theta. Cosine of theta would be, according to this, it's x over r. So we just take this x coordinate, put it over that r. In fact, we could use this, but we need to keep in mind that r, that distance r from the origin to that point, is going to be the square root of x squared plus y squared. All right, now let's look at some signs, SIG and S of trig functions, like positives, negatives, and so forth, okay? If I'm considered angles now that are maybe like this one here with the terminal side of that angle being here, I could also look at an angle that looks like this with the terminal side in quadrant number 3, or even with a terminal side in quadrant number 4. Let's see. Let's talk about this for example. Let's suppose I did have that angle that had a terminal side in quadrant number 3. What would the sign of theta be? Positive or negative? Think about this for a second. We said a little while ago, sine of theta was y over r. What is my y coordinate over here? Is it positive or negative? It would be negative, right? And r is a distance. It's a distance of this line. So a distance is always going to be positive or 0. So what is a negative y over positive r? That would make the sign negative there. And we could do that for each one of the trig functions. But what's easier is just to memorize some stuff. For example, let's suppose I have a coordinate plane here. And I want to know which trig functions positive and which ones are negative where, okay? I'm going to put this. All students take calculus. Even though all students don't take calculus, it helps us out here, okay? So what we're going to say here is that all the trig functions are positive in quadrant 1. And this S stands for the sine of theta is positive in this quadrant. And its reciprocal function, what was the reciprocal? Cosecant of theta is positive as well. Now what's going to be positive in quadrant 3 is going to be the T one. So the tangent. Tangent of theta is equal to a positive, and its reciprocal. Cotangent of theta is also going to be positive there. But all the other trig functions are negative in quadrant 3. But in quadrant 4, the only one that's going to be positive is cosine and its reciprocal. All the rest of them are going to be negative in quadrant number 4. All right, so that helps us if we think of all the functions positive here, just the sine and its reciprocal is positive here, just the tangent and its reciprocal is positive here, just the cosine and its positive and its reciprocal are positive there. All right, so that brings us to an example here. Our example is going to read something like, let P, the point, defined by -5, -7, defined by -5, -7, be a point on the terminal side of an angle theta. Be the point on the terminal side of an angle theta in standard position. In standard position. Okay. Find the values of sine of theta, tangent of theta. I'm just going to put find tangent of theta, sine of theta, and secant of theta. Well, let's draw a picture of what we have going on here first. All right, let's suppose I have a coordinate plane here. Here's my x-axis, here's my y-axis. Look at the point -5, -7. That'll be where? Somewhere around here, right? -5, -7. Now, that's a point on the terminal side of an angle theta. So I need to draw the terminal side of that thing. And let's go ahead and call this over here angle theta. So angle theta here is between what, 180 and 270 degrees, we could think of it as. Find the tangent of theta, sine of theta, and secant of theta. All right, think about this for a second. There's an x coordinate, that's a y coordinate. So x is -5, y is -7. Also, let's think about an r value right here. R is this length from here to right here. So how did we calculate r? We had a formula. R was equal to the square root of x squared plus y squared. So r would be the square root of, what's x here? -5 with my squared plus y squared. What's y in this case? -7. Let's see, what does that give me? Square root of 25 plus 49, right? Well, what does that give me? I cannot take the square root of 25 and add it to the square root of 49. It doesn't work that way. I have to add 25 and 49 first. So what does that give me? Square root of 74. All right, so now I know what r is. What do they want me to find here? They tell me to find what? Tangent of theta. So I can say the tangent of theta is equal to, how did we define the tangent of theta earlier? We said it was y over x, right? So take your y coordinate, which again is right here, -7, put that over your x coordinate, which was -5, and that'll give me 7/5. Go ahead and put tangent of theta. How about the sine of theta? Well, we learned earlier, the sine of theta is y over r. Well, again, what's our y coordinate? -7. What did we just find our r to be? Square root of 74. But let's rationalize that. Let's multiply by the square root of 74 over square root of 74. And that gives me -7 square roots of 74 over 74. And that'll be my sine of theta. All right, finally, I need to find my secant of theta. Secant of theta. What's the secant the reciprocal of? It's the reciprocal of the cosine, right? What was our cosine? Our cosine on the last page was what? X over r? The reciprocal of x over r is r over x. So what is r again? Square root of 74 over x, which was what again? -5, or I could say that's negative square root of 74 over 5, and that's my secant of theta. Let's see something here, okay? Let's see if these SIGNs match up here. If I'm in quadrant number 3 right here, I'm in quadrant number 3, my tangent should be positive. Is my tangent positive right here? Sure was. How about my sine of theta? In quadrant number 3, my sine is what? My sine is negative there. The sine was indeed negative. How about the secant of quadrant 3? It should be negative according to this. And sure enough, it has a negative sign on it. Now I want to look at something we call quadrant angles, okay? Suppose we have, find the sine and tangent for theta is equal to 3 pi over 2. All right, I'm going to draw a coordinate plane. Remember, you need to get these radian measures down. This would be like an angle pi over 2. That would be an angle of pi. This would be an angle of 3 pi over 2, right? For an angle of 3 pi over 2, that would be like an angle that does this. And the terminal side of that angle, it's going to be right here. We could draw some point if we wanted to here. We'll call that angle theta. All right, so what do I have as an ordered pair right here? Well, my x value's got to be 0 if it's on the y-axis. Then I have some y value, right? What is this r value right here? What would it be in this case? Wouldn't it be the absolute value of whatever y is? Because this distance right here is the same amount we're displaced as this y, but the y is negative right here, so I need the absolute value. All right, now what does it want me to find in this particular problem? It wants me to find the sine and tangent. So what's the sine of an angle theta? Sine of an angle theta is y over r. In this case, I could say, okay, theta is 3 pi over 2 from right here. It's equal to y. What's my y coordinate? Don't know. I just know it's y, right? Over r. What is r in this case? R is the absolute value of y. So maybe I could just call that y. But let's think about this for a second. Y over y is 1. But what I'm not sure of is the SIG in here. Well, what would your SIG in here be? Well, we don't know for that chart because it just told us what happens here, 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 and here, right? It didn't tell us what happens on these axes. Well, think about that for a second. What's my y value got to be right here? It's got to be a negative number if y is right there. So that'll be a -1. How about the tangent of theta, 3 pi over 2 in this example? Well, what's that going to equal to? Y over x? What's y in this case? I don't know, some number y, so I'm going to call it y because I don't know which number it is. Over x. What is x in this case? 0. So in other words, my tangent of 3 pi over 2 is undefined. Remember, you cannot have 0 in the denominator.